we're now moving on to Tony Scott. We're also we're also in the process of developing strategies how to contact individuals with genetic variants that drive their risk of deadly diseases, typically cancer. And Tony is spearheading that and is telling us some of his effort there.
Great. Thank you, Sebastian. And thanks for pulling up my talk. I'm Tony Scott. I'm a clinical geneticist here. That's my day job, mostly cancer genetics, a little bit of adult medical genetics, research and variant interpretation. So that's what I do for a living, but I do have a little bit of effort in precision health. So I'm going to talk to you about the role that our MGI data can play in improving precision health. So first off, to explain, what these important genes are, whenever we do genetic testing on a broad kind of exome sequencing platform for children with developmental differences, individuals where we just can't get to the bottom of their genetic disorder, we'll do exome sequencing with the opportunity to include what are called secondary findings. There's plenty of genetic conditions that are pretty silent, sudden cardiac death, certain widening of the aortas, but critically cancer. Especially when we talk about cancer risk BRCA1, BRCA2, there's no guarantee that you're going to get cancer for the most part, with bar few exceptions. So a lot of these genetic changes can run dormant in a family, especially coming down a male lineage, you're an only child. A lot of this might not come to attention until you get incidental genetic testing. So the American College of Medical Genetics has a list of 83 genes that, if they're incidentally found, do warrant recontact for the reasons I had mentioned, even if it's not for the primary reason that you're getting the testing done. Our cancer genetics clinic has a couple dozen additional genes that are actionable from a cancer risk perspective. If you have a variant in one of these genes, we're going to screen you more closely. So there's definitely a list of what I would say about 112 genes that are clinically actionable might be present in our MGI participant database, but kind of flying under the radar. These patients may or may not have had that testing, so can we reach out to them somehow? How are we going to go about doing this? How many patients in MGI have a potentially pathogenic disease-causing variant in one of these genes? So what we did, again, going off of the MGI Free6 data, 80,000 patients with some data. I had mentioned, a combination of our cancer genetics and the ACMG genes. So if you have a pathogenic variant in one of these genes, basically we define pathogenicity as, number one, a clear and obvious deleterious mutation, frame shift, nonsense, intron disruption. Those are pretty, pathogenic. We can also overlay ClinVar data. So ClinVar is the database that clinical genetic testing laboratories upload their interpretations to, so we can overlay MGI data on that. And then we have some signals that are somewhat foreign to me as a country geneticist, so we're able to have some high quality data to kind of overlay as well. So we start off with about just under 2,600 MGI participants with a suspicious variant, and no one will ever accuse me of trying to get out of more work than I have to. So I wanted to ask the question: can we reduce this number somehow? Because there's definitely some vagaries in between a SNP research result, imputed results, versus NGS clinical testing, 200, 300x NGS to really get a good high quality signal. And also too, there's probably more than a few. We talked about a lot of these patients were being ascertained during surgery, probably getting a prophylactic mastectomy, oophorectomy, probably a lot of BRCA1, BRCA2 carriers out there too. So can we reduce that number by who we know has already had testing as well? A quick plug for the EMERS tool. If you're not already aware of this, Dr. Hanauer over in Pediatrics has made a pretty very effective tool to look into your EMR very rapidly at scale. So I was able to dial up clinical genetic test reports pretty darn easily. I was told that this is interoperable. I think we had a question earlier about getting other EHRs plugged in. I think the code, the backbone of it could be extended to Cerner. I forget who else, everyone's Epic nowadays for the most part. But definitely a very excellent tool I wanted to plug that helped me do this in an afternoon. So ideally I would have more, but I was down to 159 patients who had a number one MGI result and number two had a complete clinical genetics test report in the record, more than a couple dozen, they're BRCA1 carriers. So harder really for me to make heads or tails of that. So these were very clear and obvious. Our genetic counselors do a great job of putting down the specific variant. I could compare MGI results with what is seen clinically. So what I did and where the money was, I apologize for not putting up that graph that Sebastian had. Most of the patients in the this potential carrier list were BRCA1, BRCA2 carriers. And in all honesty, with the proliferation of multi-gene panel testing, we just don't test for one gene anymore. We do a pretty broad panel associated with cancer risk that actually dialed up most of the patients who had seen cancer genetics just looking for, if I put in BRCA1 into the search tool, it's so powerful. I was able to get more than a few patients who had had genetic testing not only for BRCA1 but many others. Backfilling, I think I might have 50 more patients out there I need to abstract, but for the most part, this was a pretty comprehensive list of patients who have had genetic testing already. So for 84.3% of the time it works every time, at least this first pass of data. So, I would say a pretty good, concordance in between who had a positive result in MGI and who had a positive clinical result corresponding to that MGI a signal. So a lot of true positives. We did have a couple false positives that I did want to look into more. So thank you to Brett and Emily for that. Again, to review true positives, clinical research, correlate false positives. There was a positive result in MGI, quote unquote, but we tested that gene clinically and it was negative. And looking into these 25 false positives, again, I'm going to pretend like I know what this looks like, but I know it's not right. So basically, if this is, say, like should be like a homozygous wild type, homozygous, a mutant allele, heterozygous, a lot of signal down here. So this represents one of our false positives. So this, even if you're not as familiar, you're probably even more so than I am with these types of data, you could tell this was maybe a SNP result that you're not surprised that this was a false positive. So again, this was a patient who got flagged by the computers. Maybe the Singularity can wait for a couple of decades still. Their computers aren't perfect, but definitely something where we go back through the data. Why was this patient tested clinically negative? That's going to be why. So from that, I was able to eliminate, and I used the royal I. Brett and Emily were able to eliminate more than a few more carriers from this list because of not the highest quality data, and we're down to a true positive rate of 88.1%. I suppose I run up against my time, but what I will say, even in those false positives, I don't really want to necessarily go on the record by saying it on a slide. These are also still pretty suspicious patients, I will say. Very strong histories. They have ovarian cancer. There was a signal in ovarian cancer gene. But again, by clinical testing, it was negative. Even these false positives, I think these patients would still benefit from a once-over by a genetics clinic. So definitely, as of right now, critically too, we were able to reduce our overall carrier count down to 2,100. And so again, for the most part, a pretty good successful comparison between MGI and clinical testing. If there was a signal in MGI, we could correspond that with the corresponding positive clinical genetic test results. So I have a pretty high confidence there. And again, there's probably even more true positives out there that I just couldn't verify. So I would say maybe that improves the numerator a little bit more as well. And we were able to do a little bit of quality control in real time based on this first pass of abstracted data, kind of saying, hey, let's remove these false positives, but at the same time, keeping our true positives essentially unchanged. So definitely, through this first pass, I was able to go down, a couple of hundred cases who needs to be recontacted. So it's hard for me to say, what necessarily what the next best steps are per se. There are a couple different degrees of freedom out there. we already have a cohort of patients who've already seen clinical genetics, so maybe those patients we don't need to recontact immediately. We'll go through the chart, make sure we have a corresponding report there. Thank you to Janet. She's working on a survey for recontacting as well. And then what I'm doing right now, again, going back to that pretty awesome fee code data, I can easily kind of stratify those patients by their ICD-10 codes with a family history, personal history of breast cancer, things of that nature. So, again, this is a journey of 1,000 steps, and I'm still on step 5. But for right now, I'm kind of going through that list that we've come down to and prioritizing who to recontact. So thank you, obviously, to the MGI for this opportunity. Thank you to Jessica and Precision Health for their assistance, especially on the IRB side. Omission, I should have included pharmacogenetics here. Dan, Kristen, and Amy, because a lot of that recontacting content you mentioned, not reinventing the wheel, I am definitely riding their wheels to help guide how the IRB recontacts these patients. So thanks to them as well.